Good morning, ladies and gentlemen. This is Mr. Smith, and this is 4.2 representations of linear relationships, specifically direct variations. This is a quick one-page lesson. It is 2 slides, but it is 1 page. So this should go fairly quickly. There is a lot of writing on the 1 page, though, so we'll take our time to work through this. In example 1, we have Jill makes $10 per hour at Pizza Delight. She works an 8-hour shift. Complete the table of values to track her hourly earnings. Her table of values here. The table of values here is just in the center of this table. So you can see that right here. And we'll work through that to complete it. So on the left side, we'll say hours worked. So hours, HRS for short. And then the right side, we'll say pay in dollars. Well, where do you start? Well, can you work negative hours? No, but you can work 0 hours, which means you're not working any hours, which means you get 0 pay. Okay, perfect. Next would be 1 hour, which would be $10. And we say she works an 8-hour shift, like it says over here. So that means we're going to go all the way up to 8. 2 hours, that means $20. 3 hours, that means $30. 4 hours is $40. 5 hours is $50. 6 hours, $60. 7 hours is $70. Then 8 hours is $80. So every hour she earns $10. Now I'm going to ask which of these variables, hours or pay, is the independent variable. If you said hours worked, you are correct. Hours worked. Which is the dependent variable? Well, there's only one left, and that's our pay in dollars. You don't have to include the unit. You could just say pay. What's the rate of change? Well, if we look here, we see got 20 over 2, because for 2 hours she earned $20. Or you could look at the one above, which is for 1 hour she earned $10, which just means that she's earning $10 per hour is her rate. The initial value is $0, because if we look at the very first line here, we notice that we start with 0, because you can work 0 hours. That is possible. You can't work negative hours. The rate, again, is just $10 per hour, because every hour she works, she earns $10. The equation for this would look like this. Y equals 10 times x. And if you look up here, back above in our table of values, if x is 0, y is 0. If x is 1, y is 10. If x is 2, y is 20. X is 3, y is 30. It's just 10 times the x value. That's why y equals 10x. Now I'm going to fill in the graph. I'm just going to pause the recording while I fill that out, and then you guys can fill it out shortly after. Because our max is 80. 0, 0, 110, 220, 330, 440, and it'll just continue up like this. All right, now that I have this done, I'm actually going to need to draw a line, so I'm going to pause the recording while I draw the line, because it's kind of a pain. And we're back, and we can see very, very clearly the line drawn. Notice how at the very end it is an arrowhead. Make sure you use a ruler for this, and notice how it follows those patterns. All I did was connect 0, 0 all the way up to 880. And you use the same strategy as you've used in the past to plot points, just from this table of values. If you don't recall that, go back to Unit 3 and make sure you rewatch some of those videos to remember how to plot points. It's just the X value and then the Y value, and that's how you plot your points. Okay, next slide. Example 2. The story is Larry is driving to Thunder Bay for a hockey tournament. He drives at a rate of 80 kilometers an hour. It takes 14 hours to get there. We create a table of values to track the distance from home after each hour of driving. And we got to start with our table of values. So the first thing we need to track is our hours. Hours, or HRS for short. And then the dependent variable, which will be our distance traveled. Or just distance, because I won't have enough room for distance traveled. And we're going to start with 0 hours, because you can't have negative hours, so we have to start with 0. We have to start somewhere. And obviously, he wouldn't have traveled any distance at all. Because we won't have enough room to cover all of our 14, if we go up by 1, I'll simply run out of room. I'm going to go up by 2. So for every 2 hours, and if we're driving 80 kilometers per hour, well, 2 times 80 is 160. So we'll travel 160. Remember, these distances are in kilometers. And then I'll go to 4 hours. Should be 320. 6 hours. 480. 8 hours. 640. Sorry, that's a 0 at the end there. 10 hours. 800. 12 hours. 960. 14 hours, 1,120 kilometers. Okay, our dependent variable. Well, our distance depends on the time that we spend. So if you said hours is our dependent variable, you are correct. Hours is our dependent variable. Or independent variable. Sorry, I misspoke. Independent variable. There. What's our dependent variable? Well, distance traveled. Because the more time that we have, the further we can travel, right? So our distance is going to depend on how much time we can travel. What's our rate? Well, if you just take a point here, this works for direct variation. We can just take any point, and if we take 800 over 10, this is nice and easy to see. Because 800 divided by 10 is just 80 over 1. And remember, we had 80 kilometers per hour up at the top there. So that means 80 over 1, which means 80 kilometers per hour. Our initial value, well, when we started at 0 up here, was just 0 kilometers. Just ignore that line. For some reason, my tablet does that from time to time. The rate that we're driving at, well, we just bring that over, is 80 kilometers per hour. The equation that this looks like, well, it's just y equals our rate times x. Because for every hour that we drive, we are driving 80 kilometers. So when x is 0, y is 0. When x is 2, y is 160. When x is 4, y is 320. And I'm just reading off of the table up above. X is on the left side, Y is on the right. Okay. With that said, I'm going to fill in the table now, or the graph. And there we go. We have our time and distance. Just disregard the sloppy writing for distance and time. It is very difficult to write on a tablet, and it gets more and more challenging the less space I have. I'm going to plot out these points, and one of the main points that I'm going to plot out, and there's a reason for doing this, is 10, 800, because 10, 800 is going to be exactly at this point here. And what's nice about this is if you actually draw, well, 0, 0 is another one of our points. If you actually draw a line, the rest of your points will be on that line between those two. Or not between those two, but they'll follow along that pattern. Here, I'll show you. Let me draw a line first, and then I'll show you where all the points go. Okay, so now I'm back, and I have my line drawn, and I drew it out as far as I need to draw it. What's actually going to happen is my points here are going to line up pretty much perfectly. I mean, no graph is 100% perfect. If we go to 160, should be somewhere right here. Then for 320, should be just above the 3 here, right where it hits. 6, 480, somewhere around here. And then 8, 640 should be right about here. I'm not using animations for this because you guys should know how to do this at this point. And 10, 800, 12, 960, right along that line there. And then 4, 1120, right there. There you go. And it just follows along that line. And again, no graph is 100% perfect. And our final note at the very, very bottom here where it says note, a direct variation relationship has an equation of the form y equals mx, where m is going to be our rate of change and x is just our independent variable, because y depends on x. Okay, that's it for that lesson. You guys know the drill. Make sure you get the work done, do your practice, then do the quiz at the very end once you've done all your practices for the week. If you have any questions, email me, and I'll get back to you as soon as possible.